Hello dear students, again we have a new math subject 9.2 Constructing Algebraic Expressions, page 86. So what are the objectives? First we have to know the definition of that. What is algebraic expression, why we make algebraic expressions, and then we make an example to see how this works, and then we go to examples, exercise 16.2. Algebraic expression is nothing, all what you have to do is you replace your talking about a number with letters. Why I do that? Because you like to find a formula which can work for any time, because numbers are changing. If I say, like for the example, this is I took is the school numbers of school. You know that the number of students in a school in this year is fixed. The total number equal 1,000 students. Some of them pass, some of them not pass. So I represent each one of them in a letter. Why? Because I can find then a formula, a logical formula for the total number of students in the school. But the numbers, if I use numbers, it's not fixed, because each year the past student may be more or less than the not passed students, correct? They are changing. Numbers are changing. So I want to find a formula which is fixed, that can goes for all the years. That's why I replace the numbers with letters, so that it can be just like a law or a rule that bound these letters together, and it can work for all the years. So I said that, okay, in one school, the student that they can pass, I represent them not with a number for this year, no, with P. P is the student that they passed. N is for a student that did not pass, and T is the total number of the student in the school. So I came to this formula. The total number T of the students are the students which are passed and the students which are not passed together. Okay, this formula can work for every year, but if I use numbers, no, it will be for each year individually. This works for each year individually, not for all the years. That's why we use letters sometimes to express mathematical problems. So let us find how we can do that. Now, the number of past students, for example, is double the double of the not passed student. That means the students which are passed are double the student which did not pass. They are more. Okay? How can I write this? Can I write it like this? No. Why? We know that N is for student that they did not pass, and P is for student which they passed. But it's written here that the students which are passed are double that of the student which did not pass. If I write something like this, I understand immediately from the letters that if the student which not passed are 500, also it will be for the past how much? 500. If not passed are 10, also here 10. 6, 6, 7, 7, 1,000. Why? Because N equal P. The quantity on the left equal to the quantity on the right. So whatever a number is here, this must be equal to it. But it is not that the situation is written here. The situation which is described here is not support this equation not. So what I do now is correct. Why? Because the double, the student which are passed are double the one they did not pass. So the one they did not pass multiplied by 2, then I have the real value of the P. So the value of the P is N multiplied by 2 because it is doubled. So the number of not passed students, if I give you now a value and I tell you the number of not passed students are 400, how many students that did not pass? The number, we know that N is 400, and because the other one is double, so it is 800. You know now that because it is double, we multiply 2 by N, you shall have 800, and you know now the number of past students are 800. Okay? And if you want to find the total number of the school, The total number of school will be the ones which are passed, not passed, plus the ones that are passed, and it will give you 1,200 students. So the total number of the school is 1,200 students. They are consist of two groups, a group of not passed, which is 400, which I gave you, and the one which are passed, which are 800, and you find it out from this equation. From this equation you can find the one that are passed, and you can find also the total only from knowing one of the terms, which is the student which are not passed, and they are the 400. Okay, so that's why I represented here the letters, the numbers with letters here. You can use this, for example, and this for each year. Next year or the year after that, when the students are not, the ones that are not passed are not 400, but for example 350, you can find also the students which are not passed, and you can find also the total number of the students in the school, all because you have already constructed an algebraic expression which represents the total number of the students in the school, and another algebraic expression which represents the relationship between the students which are passed and the students which are not passed in the school. That's why we sometimes represent the numbers with letters, so that we can find an algebraic expression that can work for all the years, or something fixed that I can use anytime to determine a certain mathematical situation. So now we go to example exercise 9.2. Let us see how that. Let us see some exercises in the book. Xavier thinks of a number n. Okay, there's a boy, a guy. He thinks of a number n, which represents a number. N stands for a certain number. Okay, we don't know how much is this number, and we don't care. It can be 7, 8, but we care that write the expression when multiply the number by 7. Important is when I multiply this number by 7. So it is n times 7. So I constructed now n times 7. I constructed now an equation. This is an algebraic expression which can work for many years to come. Why? Because every time a number comes in the variable n, or in the letter n, will be multiplied by 7. I am saying in this algebraic expression, hey, n, whatever you bring me from a number, you will be multiplied by 7. 10 multiplied by 7 will be n 1000, it will be multiplied by 7. And this is, we shall see how important it is by programming in the future. When you program something and you make such an expression, you are telling the program whatever the variable n will bring me from a value, it will be multiplied by 7. So this is your algebraic expression, n multiplied by 7. By c is the same, subtract 2 from the number. The number is still n, you only take 2 from it, and the third one, add 2 to the number, then multiply the result by 5. Now we have two steps. The first step, you add 2 to the number, so it is n plus the number, okay, plus a number, and the result, that means the result, the equal, what's equal from that, you will multiply it by 5, the result. You can express the result by keeping the first step between brackets, okay? This means that add 2 to the number, that means I added 2 to the number between brackets, means after I find the result inside the bracket, I will multiply it by 5. Not before, no, after. The bracket means the bracket have the strongest priority in mathematics. Whatever is inside brackets, you have to finish it before you go outside the bracket, okay? So if it works. So everything is inside the bracket now, you have to finish it. After you finish that, you multiply it by 5. So now try to do these exercises, please. In page 86, exercise 9.2, exercise 9.2, also number 1, B, D, F, and number 2, A and B. Try to do it at home. Take pictures, send it to me by WhatsApp. I shall correct it for you. Thank you very much.